Alright, today we'll be going over another set of permutation and combination questions. Alright, I'm trying to see if I can hit 20 subscribers from this video, so please hit the subscribe button and let's get the party going. Alright, here we have our first question. It says 4 men and 4 women have to be seated in a row such that all the men are together and all the women are also together. In how many ways can they be seated? Alright, so let's look at this question. Now we have 8 slots. 1, 2, 3, 4, 5, 6, 7, 8. Now we have 4 men and we have 4 women. Now they said they must all sit together. So let's say 1, 2, 3, 4. So if this is men, if these are men and these are women, so you can see 4 ways of arranging men is going to be 4 factorial. 4 ways of arranging women would be 4 factorial. Now when you look at this, it's almost like we have just 2 boxes when you compress that of men and that of women, so that will be times 2 factorial. So from here you can multiply out. So 4 factorial, that will give 4 times 3, that's 12. 12 times 2, that's 24. Times 24 times 2, you can go to the side and multiply. So 24 times 24, 4 times 4 is 16. Alright, 6 keep 1. 4 times 2 is 8 plus 1 9. 2 times 4 8, and 4 times 2 times 2 is 4. So from here we're going to have 6 7 5 now times 2, and 6 times 2, that's 12. 2 you keep 1. 14 plus 1 5, you keep 1. 10 plus 1, that's 11. So that is the answer to that question. Now because they must sit together, it looks as if we have just 2 bunch, so that's 2 ways. Now arranging 4 men, that's 4 ways. Arranging 4 women, that's another 4 ways. Alright, let's look at the second question here. That's question 14. It says 4 managers, 2 vice presidents and 1 president have to be seated in a row for a meeting such that the 2 vice presidents sit on either side of the president. In how many ways can they be seated? Alright, so for this question we have 4 managers, we have 2 vice presidents and we have 1 president. So the condition states that a vice president must sit at the other, like at 2 ends of a 2 sides of a president. So let's we have 7 slots here. 1 2 3 4 5 6 and 7. So let's say there's a president here. It means that there must be a VP here and there must be a VP here. So when you look at this critically, these 3, they look more like a bunch, so let's call it 1 2 3 4 5. So we're going to have 5 factorials. Now these that means the vice president that will be staying at both ends, it's either you're here or you're here. So we have 2 ways of doing that. So when you multiply out 5 factorial, that's 5 times 4 times 3 times 2. 5 times 4 is 20 times 3, that's 60 times 2, that's 120. Now 2 factorial is 2 times 1, that gives us 2, and that's 240. Okay, that's that for that question. Now the last question here says, in how many ways can 8 cars be parked in 8 parking slots in a row such that there are exactly 4 cars between 2 specific cars? Okay, we're looking for 8 slots. So we're going to have 1 2 3 4 5 6 7 8. Now it says there must be 4 cars between 2 specific cars. So let's say we have the first specific car here, 1 2 3 4. We're going to have another one here. So let's draw another set of boxes. 1 2 3 4 5 6 7 8. Let's say we have a specific car here, 1 2 3 4. We're going to have another one here. So let's draw another 8 boxes. 3 4 5 6 7 8. So let's say we have a specific car here, 1 2 3 4. We're going to have another one here. So these are the possible arrangements that we could have to have 3 cars. So now when you notice, we have used this position and this position. So since they are fixed, it means they are 1 unit. So we have 1 2 3 4 5 6 left. So we're going to have 6 factorial times, now this arrangement, this is 1 2 and 3, so times 3 times, now these 2 cars, they can be placed in 2 ways. This one can be here, the other one can be there, so times 2. At the end of the day, we have 6 times 6 factorial. Alright, thanks for watching and don't forget to subscribe. I will see you in. Alright, today we'll be going